Okay. Thank you all very much for coming today. This is a hybrid event. And so there are about 25 people here in the room. And we have how many people online right now? 24. So about equally split. Because the people who are online sort of typically expect events to start close to the actual starting time, and sometimes in-person events start 5 minutes late. So we tried to sort of go right in the middle. My name's Eric Howard. I'm the executive director of the E2 Tech Council, the Environment and Energy Technology Council, and I'm pleased to be working with the Rue Institute on a whole series of lectures, webinars, and seminars, all related to artificial intelligence, climate action, and the Climate Incubator that the Rue has launched this year. It was almost exactly a year ago when we started having these conversations about the Climate Incubator between E2 Tech and the Rue. They are definitely the lead, and we're very happy to be a partner with them on this project. Our first speaker in this series is John Wallace, who's here in the room with us. I'll be inviting him in a couple of minutes. He's an entrepreneur in residence with the Rue, and he'll be introducing himself and talking a little bit about his background and what is going on here in Portland, Maine. Lots of things are happening, not only in Portland, but statewide. The governor recently had an announcement about the 15,000 clean tech jobs in the state. And part of that announcement was a desire to try to get it to 30,000 clean tech, clean energy jobs in the state by 2030. And so going from 15,000 to 30,000 will involve entrepreneurs, people who are forward thinking. Where are some of these people? There are a number of different graphs or metrics one could use. I pulled this off of the Efficiency Maine page. These are all the companies that work with Efficiency Maine to install heat pumps. You may be familiar with the 350,000 heat pumps that they're trying to install to help homes in Maine get off of oil heat. E2Tech's been around for 22 years. We've got hundreds of member companies, thousands of people on our mailing list, and many partners, including the Rue. And we are a membership organization, so say we'd be glad to see you. Everybody who's registered for this will be on our mailing list to be invited to future events, not only the collaborative ones that we're doing with the Rue, or that the Rue is doing with us, but also ones that we do on our own, or the ones that the Rue does on its own. We convene gatherings like this. We're a catalyst for growth. The E2 Tech Council, we also do some research. We provide information to government agencies, to businesses, and we're a connector. Here we are at the Rue Institute in downtown Portland. The building's been here for what, a year and a half, 2 years, something like that. And I joined the E2 Tech Council just a year ago, so I don't know all of the history of everything. And here we are. John, come on up. We welcome you to the podium, and thank you very much for being our opening speaker. One more thing. For the people who are here in person, we will have ice cream coming out at about 1:30, 1:20 over here where the drinks are. Okay, sure.
Yeah. Thank you all for coming. Just as a reminder, if anybody has a hard time hearing either online or in the room, let us know and we will do our best to take care of that. Thank you all so much for coming. My name is Tara Dunham. I'm the program manager on the Climate Tech Incubator here at the Rue, who is hosting the speaker series in partnership with E2 Tech over the next year or so. Warren Adams is here. He is the director of the new incubator, and we'd love to talk to you and engage with you more. So we are just launching. We'll be having a public launch in September, announcing everything that we're doing. But our applications are open. We're starting to build this community and ecosystem of startups here in Maine working on climate tech businesses. So thank you all for coming. And with that, John, we look forward to hearing from you.
Thank you. All right, good early afternoon. Can you hear me okay in the back? All good. Eric, thank you for the introduction. You as well, Tara. Appreciate that. And the ice cream I didn't know about, so please save me one before it goes on there. Okay. So thank you again for the opportunity. A big thanks to Warren Adams and to Tara Dunham for the kind introduction and for inviting me to join as an EIR at the Climate Tech Incubator here. So what I'd like to do before I start into my talk, I would like to just preface this talk with I put this together in about 2 weeks, maybe a little less, and I wanted to just say this is informal. You're eating lunch. I want to make sure we keep this high level from the lens of startups. Maybe you're interested in a startup at the incubator here, or you want to support a startup. So this is high level business focused. I do teach the graduate course on applications of AI and energy at Northeastern. I've been teaching that for 5 years now. We're starting year 6 coming up this fall. If you're interested in using that course to help you kickstart your pathway into AI for energy for, let's say, a startup, let me know. I'm happy to talk to you about that. There are some prerequisites for that class. So anyways, let me go ahead and start off here. A little bit about myself before I get into the talk. I've been involved in energy for over 25 years. And in that sort of role, I've worked in energy sort of sources from fossil fuels to renewables and a little bit in between in terms of decarbonizing the environment. So worked in that space from a technical role to also an investment role as well. So I worked in deep technical roles for quite some time up through a program management role with a large sort of new technology development in the space. And then investments, I worked about 3 to 3.5 years in investments for a private equity firm. We invested in oil and gas, in renewables, as well as carbon capture opportunities. So quite a few roles there. And I've been involved with university for the 5 years I mentioned. Plus, I run a consulting firm on really applications of AI and energy. And thanks to the incubator here, I just started a new company called Flight Sage, which maybe I can tell you a little bit about at the end of the talk here. All right. So the talk, again, is high level. I would like to focus on really how AI is impacting the energy transition. Okay, I would like to start off with an introduction to really the call to action. Why would we want to use AI to help with energy transition? Why now? Then get into a brief history of AI with one slide from Aristotle to quantum computing. Believe it or not, we can do that, and in the time frame that we have. And then discuss some applications of AI and energy, again, from the lens of what are some emerging opportunities, both technology and the application areas. Okay. For the introduction, so here are some famous quotes from some people you probably know about. So Mr. Bill Gates was interviewed in 2017. After he finished a long career at Microsoft, they asked him, if you were to start over again, what are the 2 areas that you would focus on? So sure enough, he said, okay, AI and energy, and for all the right reasons, right? Another famous person, Elon Musk. Okay, so he's one of the proponents of generative AI and all that it can do to move us forward in humanity. He and Stephen Hawking are also, they raised awareness about the potential pitfalls and risk of AI. So there's a famous saying, these are very, positive sort of quotes with a cautionary statement from Stephen Hawking. So, okay, so now let's talk about the call to action. So I'm sure all of you are aware with the climate change that we've been measuring for decades now. And as you probably know, you've seen it in the news, climate records continue to fall. So before I mention the climate records, we know that we've been using fossil fuels for quite some time. So fossil fuels displaced whale oil back, quite some time ago in the late 1800s to early 1900s. And there was an exponential growth from about 1940 to 1960, 1970. And then we've been on a much steeper increase in the use of fossil fuels ever since. They consist of about 80% of the source energy that we use worldwide right now, okay? So lots of folks, a lot of you are probably working in renewables and associated companies and sub-industries. It's still a small percent of the total slice of the pie. Okay. Also, we've been measuring the atmospheric CO2 concentration for quite some time as well, from ice cores to measurements in the air from locations like Hawaii, for example, and that's been increasing every year. So as a consequence, this is a slide or a graph from NASA showing the average monthly temperature anomaly by month and by year. So left to right, January to December. The bottom line in dark blue, that represents a close to pre-industrial time, 1880. So that's cold blue. And then this top line here with the circles on the data point, the highest red color is the year 2024 so far. As you can see this year, and going back for the past 12 calendar trailing months, is the first year on record that we've been consistently month over month over the 1.5 degrees Celsius of heating that we've been trying to avoid with the Paris Climate Agreement in 2016. So it is a bit eye-opening to see this. You can do the quick math there. You can go up and down the vertical scale for the temperature anomaly month by month. You can see that it's at 1.5 for that spread there. And that's between 1880 and 2024. And we're looking at trying to cap the heating that is at 1.5 degrees ideally with reference to pre-industrial times. So that is truly the call to action here, right? Call to action meaning we really need to accelerate energy transition, and that's one of the main points of the Climate Tech Incubator. And so let's move on. With the current energy flow, this is a energy flow data from Lawrence Livermore National Laboratory, the last time they reported it for the year 2022. On the left, you have the sources of energy. On the right, you have the uses of energy. So the sources are dominated about 3/4 to 80% fossil fuels. And then on the right, you have the blue line at the bottom. That's useful energy that we're putting to useful work. And about 2/3 of the energy that is going into the energy chain, so to speak, is waste energy, okay? All right, so on the source side, we're still dominated by fossil fuels. Lots of opportunities to decarbonize on the source side. On the use side, plenty of opportunity to look at building efficiency. Efficiencies all around, from transportation to building, energy management, for example. I just met Danny from Train Corporation, and his company is using AI to focus on just that, really starting to really mitigate the carbon emissions by tackling building efficiency. All right, so there's opportunities on both sides and lots of places in between. Okay, so that's the intro. That's where we are. Yes, go ahead. This is informal. Feel free with a question. Oh, yes. Yes, the rightmost column, let me explain that. That's the question. You have energy services in blue, rejected energy in orange, and the blue energy services, that's basically useful work, useful energy that's put to work that we benefit from. The other slice there, rejected energy, is wasted energy. Nobody can use it. So it's truly an area that we could find a major gain in efficiency and start to capture some of that useful or wasted energy, that is. For instance, combined heat and power is a very useful technique in thermodynamics to tap into some of that waste energy and put it to work. Right. Thank you. Great. So now, okay, a little bit of history on AI. I get pretty excited about that. After such a somber, dire topic there, let's talk about, there is hope. Obviously, we're here to focus on that, what we can do about it. So let's talk about AI from a historical perspective. And I'm really quite fascinated with this slide because somehow I was able to fit the full history of AI back to Aristotle in the year 320 BC to some period now where we're looking at even quantum computing. So in the early days, pre-1900s, we actually laid the groundwork mathematically for AI all the way back to the logic statements. A lot of us use that in programming, logic, true, false, right? Well, that actually had to be constructed by humans, and that was one example of many of precursors that leading up to AI. In the early days, we had a lot of effort in the early 1900s from several researchers that were on the topic of AI. And then the birth of AI occurred in 1956, at least historically recognized as the year of the birth of AI, with Professor McCarthy and his 2-month workshop there. So at that time, they gathered all the experts around for a 2-month workshop, and they really looked at, okay, we have all these different disciplines. We're all talking about roughly the same thing. How do we crystallize this into its own discipline? And then how do we propel this forward for humanity? So it was a great time point there. Adolescence period, 1960s and 1970s. I have a teenager, so I think those of you have teenagers, we've all been one. Now there's an early growth, like growth pains, if you will, in the industry. And then into the 1980s, we had basically a lot of researchers working mainly off of government funding that had really, they were visionaries, they could see the potential for AI, and they were professing that potential, but at the time we did not have the maturity, the technology mathematically, from software to the methods and algorithms, and especially the computers. They were greatly limited at the time. So it was a situation where we were over-promising and then under-delivering, so a lot of the government funding dried up in the AI winter period from 1987 to 1993, okay? So without getting into when I was born in that area there, I'll just say that I grew up in that period, in the AI winter. And then the next period that I'm focusing on here is the age of the AI agents. So I think all of us have a smartphone, most of us, and most of the smartphones that you have you can actually speak to Siri or some equivalent of Siri where you can actually interact through spoken language with the device. We take that for granted. That's an amazing sort of example of AI, and it came out in the latter part of this period when there was a proliferation of all these smart devices. This is also the age of IoT, the early onset of big data, where all these devices being sold and used everywhere around the world. We've had this explosion of data during this time. So, all right, so AI agents, you have IoT, Apple's first iPhone, Siri as well as IBM's Watson was developed and unveiled in the year 2011. So that went on to beat the world chess champion along this bottom row right here. So on to the more modern era here is on the left. I've got 2007 to 2015 was where we had major advances in computer audio and computer vision. So we actually had, let's see, AlexNet. So those of you that have run the convolutional neural network called AlexNet, Alex was a graduate student in Canada at the time. And so on his own, with some help from his researchers and his professor, he competed in the competition at that time in that year and won the competition with basically his convolutional neural network that we all use to teach now in class. And we can run that in a fraction of the time compared to when he was actually working with that. So really good ground point there. NVIDIA came out with GPUs that were originally for games. Now they are being repurposed with the drivers to be able to accelerate training AI models. So very fascinating there, and that's sort of underpinning a lot of what's to come after that. So in that period from 2015 to 2019 is kind of the era of deep learning advances. So you had basically Google published the concept of the transformer, the mathematical way to create modern deep learning neural networks and how to train those. And Google came out with a concept of TPU, hardware that was designed from the ground up to be able to facilitate training neural networks. So a TPU, tensor processing unit, okay? And what I want to point out here as I go across this line here, as I mentioned, each of these areas of computer vision, computer audio, deep learning, during this time period with trials against the average human IQ demonstrated for each of these areas, being able to recognize images, being able to identify patterns and features in the images, audio to language. In each of these sort of categories individually, AI has been surpassing humans, okay? And then on to the age of generative AI. So with generative AI, it really the underpinning there over the past few years, we've all heard about ChatGPT. I think everyone, even my kids are using ChatGPT. So it's really everywhere. But this is the underpinning of that. So it's a multimodal neural network, meaning that it has the architecture to understand tabular data, numeric, categorical, is the architecture to benefit from all the prior periods of computer audio and vision, as well as video, and then also turn that around and generate new content from that training material. So quite fascinating there. And we're all benefiting from that. So if I ask for a show of hands, I think just about everybody would raise their hand if I asked, are you using some form of generative AI in almost your day-to-day work? So there's someone who want to participate? Absolutely, right? So, I mean, let's do that really fast. So raise your hand if you use some form of generative AI, even on a daily basis. Okay, weekly. Weekly? All right, great. So most of us in the room. Excellent. Okay, and there's quite a bit there. There are more hardware technological advances that are coming out really every month, and it's really accelerating fast. But let's go to 20XX. So what does the future, near future to mid future hold? I think, and this is just a prognostication of, you know, looking at where we're going, let's say taking quantum computing, which can greatly accelerate and expand the amount of information that can be processed. So with 2 qubits, let's say quantum bits, you can handle at least 4 bits of information. So this exponential increase in the amount of information that can be used for training and calculations that are associated with that. And then also looking at being able to parallel process. So quantum mechanics with a quantum bit, it can exist in multiple states at once, which has the underpinning for parallel computing at the highest level, I think, compared to what we have with traditional technology. So let's watch this space. IBM and MIT have already come out in 2019 with a demonstrated example of using quantum computing to implement machine learning. So there's a lot moving in this space and a lot's to come there. And could we reach general intelligence where AI can surpass humans across all categories in the near future? I think that's possible, right? Okay. All right, so the history of AI in one slide and hopefully less than 3 to 4 minutes. All right, so just a quick sort of focus on that point there. My first artificial neural network that I created was for the Air Force to look at jet engine diagnostics and prognostics. Okay, I was the only grad student in engineering that I knew of, you know, running neural network models, and only the professors and researchers in the computer science department really understood it, and we just had a black box. But back then, this is the kind of architecture that I was working with. So a real simple, as one of the attendees is shaking his head, yep, that was the early days, right? Simple multi-layer perceptron where you have on the left, you have the input variables coming in. In the middle, you have hidden neurons that make calculations in an output. But the number of parameters was just a few hundred parameters, and I spent about 4 weeks to train that. Got the answer. It looked great from an accuracy standpoint. Overfitting was minimal, but I really didn't understand it, right? But it took me like about a month to go through that whole process. Well, now when I teach my graduate course in AI, we can do this during a class lesson. It's that fast. Okay, it's matured that much since then. Okay, so let's go from 1998 when I was working the simple neural networks and to something like today with multimodal neural networks for generative AI. This is a simple concept. It's more complicated than this even, but on the right, this is more modern. So you have on the left here, in this whole entire architecture, you have the mathematical sort of neurons that pass information from the input to the output. That's more of a traditional MLP, but much more sophisticated, handling typical like numeric data, for example. In the middle, you have basically neural network architecture that can process images and video, multimodal. So you have text, numeric, images, video, and the far right brings in the time domain. So the far right is an example of a long short-term memory, recurrent neural networks, which can be used to incorporate time information into the training of a neural network. So this is truly, I think, cutting edge, and this is where the latest sort of state of the art is. Okay. So we have throughout this advance in neural networks, again, just the history of AI and the recent advances, I have a large family. Keeping track of all the techniques, I basically have, let's see, 9 aunts and uncles on one side, 5 aunts and uncles on the other side of my family, and cousins and second cousins. So it's hard to keep track of everyone. So when I look at the family tree of neural network techniques, I have a hard time keeping up with that. So I took some time here. I'm not going to go through it in detail, but I'll give these slides to the audience later. But what I've done here is I've classified of all the techniques out over time. You have the older techniques from the early days, modern techniques, which is something you might be taught in classes these days in graduate school, and on the right, state of the art, which is probably more like advanced masters, maybe to PhD students, maybe to industry researchers, and folks at the fame would be like Facebook, Amazon, and I forget the NVIDIA maybe, and then Google. But anyways, so on the right is truly cutting edge, and then the vertical rows would be the various activities you would use these techniques for. So you have clustering at the top to get better understanding of your data, hidden structure there that you wouldn't otherwise see with the human eye, classification to look at cases where you're looking at non-numeric responses, let's say fault diagnostics and energy systems. And so that's for use classifications to left to right. You've got the vintage state-of-the-art techniques. Regression learning, that's the third row down, and that covers basically a lot of this work regression, right? In Excel, you can use the softman and it fit just any polynomial model. So this is, regression learning, but much more powerful, right? And then finally, the new row here that I added is generative AI. Believe it or not, we had examples of early generative AI back several decades ago. In fact, the first one of the first sort of self-driving cars actually dates back to like the 1970s. So it was back to generative AI. So on the left here, we had early AI sort of concepts in the 60s and 70s to today's sort of self-supervised learning with large language networks for large language models for generative AI. So quite interesting there. I'm happy to give you references for these if you like, later after the talk. Okay. All right. So what I want to just wrap up with in terms of the history of AI, we've been using energy more and more as a society globally, ever since the Industrial Revolution. I showed you the graph with that rapid increase in use of energy. And we're basically using the equivalent of, let's see, about almost 2,000 terawatt hours of energy every decade and about 180 terawatts every year. So quite a bit of energy. Okay, so that global energy consumption blue line is the upward trend. But let's look at the green bar chart there. That would be the number of publications by decade where there is some work dealing with AI applied to energy systems. So that was the search that I ran in ProQuest. There were actually a few in the 1970s. Tech companies and telecom companies had about a 10-year head start on the rest of us in various industries. And then we see the slight increase in the 1980s, 1990s, 2000s, and a dramatic increase in the 2000s to an even steeper increase to this decade. And we're only halfway through. So one item there, we had the dire topic of the call to action in terms of climate change that appears to be accelerating. Well, guess what? We're accelerating our use of AI and energy. So this is encouraging just by looking at publications and the associated activity around that. So great. All right. Okay. So now let's get into the energy landscape, and I'll go through a few sort of thumbnail examples of how AI is being used in energy. On the left here, left to right, this is a linear flow of the energy value chain from finding energy, developing it, transmitting it, delivering it to market to the end user. Okay, left to right. This is a lot to cover, so I'll try and go through this quickly. Left with exploration, usually that's associated with the oil and gas, but also with. Okay. That's good. Yeah. Okay. On the left is the exploration of energy sources, oil and gas, but renewables, looking at where the best potential is, generating energy over to transmitting and distributing it, and finally the end user. So what I'll do is just go through a few of these and point out just with a few sort of statements of how AI is already starting to be applied to each of those areas. So common approaches in exploration for energy would be using drones, computer vision, satellite images, and a lot of other advanced sort of geophysics sort of techniques, such as subsurface seismic to LIDAR and other techniques. So quite a bit there. There's a tremendous amount of data. If you think we have a lot of data now with our cell phones, going to look at satellite data, there's a tremendous amount of information there, and quite a few startups in that space that are using AI to harness that data to accelerate energy transition and help with exploration. In the development side, that's after you've already selected a site for development, and there's a lot of weather-dependent forecasts and AI associated with improved weather forecasts that help with development and looking at the right sort of design that you need for that site and what sort of requirements that it has. Aerial imaging with drones. Drones are a relatively new technology that a lot of those are now autonomous, so you can give them a pre-programmed flight path and they can fly that basically automatically. All right, and gather that data that couples that and integrates that with satellite images. Also helpful in that area there, but also on the design side. So there are AI design techniques that that use AI to improve design. So explore design techniques in such a way that it can explore techniques a lot faster than we can and cover really finding that global optimum faster in terms of all the constraints that you have in optimization. Okay, moving on to generation. Once you have an operational site, we're already seeing quite a few applications of AI to monitor the operation of the site, for instance, with digital twins, creating basically an entire computerized model that replicates the real operating system in energy, and then being able to use that to make predictions on when you need preventative maintenance to avoid unpredicted maintenance, and also to help really optimize the whole system to improve its performance. And in terms of renewable energy, so this is where we have, with renewables, we're at the mercy of the weather, especially the renewables at the surface, solar to wind. And so this is where there's a major effort underway to couple renewables with long-term storage to basically optimize that equation. Okay. On to transmission and distribution. So if you think that we have a lot of data that we're gathering, there's also a tremendous amount of data being gathered just by the grid itself. So the grid in the US especially covers a vast area, and in lots of places they've been adding more and more sensors to gather that information. So that big data opportunity is another area where AI is being applied to really monitor the health of the grid to make sure it's resilient to various sort of, let's say, bad actors and hackers, but also to one of the other coupling effects of climate change, extreme weather as well. So a major advance there, okay? Then on the consumption side, I think Danny can attest with his company's work on building energy systems. There's quite a bit that we can work on there as well, and we've already started. So building automation systems to look at monitoring the digital footprint of all the systems in a building, for instance, here, and how it's operating, and how to optimize that to minimize the use of carbon emissions and maximize efficiency. So quite a few items there that are already being used. And that's a quick run through left to right from source to use in the energy value chain. Okay. Now I just want to take just a quick run through. We're going to run out of time in just a few minutes, but these are some thumbnails, some actual examples with the problem, the solution using AI, and then the impact. So one of the big items, especially with a climate tech incubator like we have here, one item that traverses all of the considerations with energy systems across the board is the weather, right? So being able to predict the weather more accurately is a major advantage, anything from not just renewable energy, but I also have worked in geothermal energy. That's below ground where the source of energy is. Well, guess what? The system at the surface is at the mercy of the weather in terms of operating efficiency. So I'll leave this to you later. You have a link here, but Google has a new sort of architecture of neural networks called GraphCast, which basically has discretized an entire grid around the world and has infused the basically deep learning neural networks into that grid. And you have a much more accurate forecast that can be run in a matter of a minute or two compared to the conventional physics-based models that take 10 to 20 hours to run. Okay, fascinating there. And you can run this actually in a matter of minutes. You could actually run it during the talk. Don't do that right now, if you don't mind. But you can actually run that, and this is actually an output. It's virtually indistinguishable from the actual data that it was used to train that. So you get full weather patterns from surface to at altitude, predictions on wind speed, direction, temperature, and whatnot. Okay. On to the next. This would be geothermal startups. So geothermal energy has seen a surge, another sort of revolution and looking at how we can tap geothermal energy. There are 4 companies here that I'm highlighting, from Fervo Energy all the way to Zanskar. All 4 of them are startups. I think if I did my math right, the amount of VC venture capital to private equity that they've raised, I think it's close to $1 billion from just a few companies here. So this is a major area to watch. And all 4 of these companies have touted that from day one, they've been using AI to accelerate their learning curve and leverage data to maximize their pace of innovation. Okay. Another item on geothermal energy. This is a quick plug for some of the work from a professor from Brown University, one of the experts in physics-informed neural networks. You can now couple numerical simulation, take the advantage of that with AI deep learning, combine the two, and actually fuse them together to have a much more superior type of combined hybrid model. This is an example here where this application of that technique will take a simulation that's actually fairly coarse scale. It runs in 4 hours. Larger models that I've run myself could take a few days. 4 hours down to less than a second to run that same solution. So quite fascinating there. Also in offshore wind, this is of interest to the great state of Maine. There's plenty of potential for offshore wind in this area, as we have down the coast towards Maine and the Cape there, where we've already seen companies develop and put on production large offshore wind turbines. And so in this area, there are already companies, a lot of companies out of the EU, out of Europe, that have actually taken AI to apply that. This is one example from Action. This is out of the EU, and they're using basically a test bed, an offshore wind platform that was instrumented heavily with sensors for public research. And they've taken this to where they've created a digital twin of that to help optimize the performance of these, demonstrate the optimization and performance of these types of systems. So there's quite a bit of activity there. Okay, one last item, 2 last items. Fusion. Researchers from Princeton University just recently published a nice article in Nature where they have used neural networks to stabilize the plasma in fusion energy, and they've already demonstrated that it works. And they can take that to basically what would have taken several seconds, 10 to 20 seconds to stabilize. Now they can do that in a millisecond and use the AI to, in real time, learn how to properly control that plasma fusion process there. So quite fascinating there. And a talk wouldn't be complete without ending on quantum AI. I've already mentioned it. I stole my own thunder. But with quantum AI, you can handle much more information with the same amount of equivalent sort of material or hardware. It's different hardware, but the same. So we have major sort of advances in terms of being able to handle more information. We've already got major sort of milestones here from researchers and companies demonstrating application of using quantum computing to implement machine learning. So watch this. This is an area to watch for. If anyone's working in this space already at the RU or at the main campus, it would be great to reach out to you to see what the latest and greatest is in this area. All right. So in conclusion, I hope you see the call to action. So the numbers are real. It's really clear that we need to move faster in energy transition. I hope you see that with these slides that there's a pretty good indication that the technology is mature or maturing enough to really tackle and use that in a commercial environment. AI is for everyone. So a lot of this that I showed here, you can run on your own. Happy to show you the code for that. We have a growing amount of venture capital and private equity in this space, and some early movers from publicly traded companies that are also investing in startups in this space. So it's a great time where all this is falling into alignment, and an excellent time to work with and potentially join the Climate Tech Incubator here at the RU Institute. With that, thank you for your time. All right, thank you. We'd like to open the floor for questions. I think we'll take some questions here in the audience on campus, and I'll work with Tara to work with some questions we may have from online. So I think gentleman here was first.
Like the data processing itself will get more energy efficient with some of this evolution, or is that
Yeah.
like a fixed relationship?
That's an
More processing.
Yeah, excellent question. If I can paraphrase, basically that you're asking about, what is the demand on computation to handle just gathering and processing the data before we can even use it in AI? And and can we handle that now with the current state of the art technology? So what I would say on that is that amount of data that we're gathering in the years 2018 to 2021, we gathered more data around the world than we had gathered in the entire history of humankind before that. Okay, so to your question, the amount of data that we're gathering is exponentially increasing every month. The data centers necessary just to hold that data, let alone compute with that data, they are also growing exponentially. So just this last year, I think there are estimates that AI-based, our data centers in general, were consuming about 1% to 2% of global energy demand. And just over the next 5 to 10 years, I can provide a reference for that. A lot of research groups are estimating that that demand for data centers alone could reach 8 to 10% in 5 to 10 years. Okay, so that on its own is an exponential sort of curve. And could we reach singularity? I think a lot of us have seen that concern there. Could the data center demand for AI surpass available energy that we have? If that's a separate item, I'll just add that to the answer. I think with technologies like quantum computing, which can handle more information for the same amount of energy, we will continue to find solutions to that. Good. And I think we had another question behind you there.
Failing to meet their own climate goals because they know they comments on that research that is how like that might be remedying the issue of accelerating climate change issues caused by
Yeah, great question. So the same companies that run data centers are also, just like a lot of corporations, they are trying to reach targets to decarbonize by a certain time periods to help with the Paris Agreement from 2016, and also their shareholders want it, right? So there's a major sort of percentage of shareholders that really want that change. You're right. So a lot of examples where they are, like a lot of corporations are missing targets. Okay, it's I think across the board. I wouldn't single out one particular industry, but they're also in that camp. What I've seen, I can only talk to a few items that I know about. What I've seen are companies like Google, the Amazons, Microsoft. They are turning quickly to renewables. For instance, Google just signed, I believe, about a 200 to 300 megawatt PPA with Fervo Energy, one of the companies I showed in geothermal energy, and that is 100% clean energy. And that is actually at a data center in Utah, one in Utah and one in Nevada, that is right there on top of one of the best areas in the US for geothermal energy, and that is 100% renewable. So they are moving fast to try and reach those targets. I just don't have the actual data to see are they going to be able to meet those or not. But that's one example. They are moving on that. And then the fastest we can work together to help accelerate that, the more we can do that, right? So next question.
do you foresee the future being that oil and gas kind of ideally would stay consistent and then renewables would continue to meet growing demand? Or is the idea of replacement even feasible as it's consistent?
Yeah, again, this is just my own opinion from 25 years, but everything's biased in terms of what you can see. My own opinion on that is that from what I can see, fossil fuels will dominate the high percentage of energy source supply for decades to come, I think. We want to decarbonize as fast as possible, but the infrastructure is already there. We would probably get into tipping over economies to really going into slumps and recessions if we go too fast. So what oil and gas that I can see is doing to help address that is there's a growing amount of investments and activity in capturing CO2 out of the atmosphere and sequestering that underground in the oceans with growing more plants. Everywhere you look, they're looking at that. In fact, if I could put in a teaser for my own startup, we are looking at an easy way to quantify your emissions, carbon footprint, easy ways to reduce that. And then the rest, you can go right into the open market and not just buy carbon offsets, but buy and purchase carbon removal units where you actually can quantify the amount of CO2 in tons that is being sequestered for at least 1,000 years. So that's in our lifetime. That's okay. That's long-term permanent, right? For our practical speaking. So yes, that I don't think it would move fast enough to see a major drop in the use of fossil fuels, but they are working on a solution to where we're still emitting, but we're sequestering that out of the atmosphere and putting that back, for instance, underground. So go ahead. Um, yeah.
We have 2/3 of it wasted.
Yeah.
How do we use AI to change that? Viking power is great, but it's a very difficult system to install, and district heating requires underground piping. These are hard infrastructure things that. So how do we apply AI in the value chain of efficiency, using the lost possible?
Yeah, great question on the efficiency side. There's so much to gain there in terms of decarbonizing. We have aging buildings everywhere around the world, especially in the US here, aging infrastructure. So to go and replace everything would be cost prohibitive, right? Just to reach our targets for preventing reaching 1.5 degrees C would cost, they're estimating from the World Economic Forum, $100 trillion to $125 trillion, which is the global GDP. So on that, AI can be used to help us understand our current usage, where there are humans in the loop where we can change our behavior. That's the fastest way to get even like probably 10 to 15% reduction in carbon emissions just by using the existing buildings we have more efficiently. And then the retroactive retrofits to purchase and install insulation to systems that are more efficient. My friend Danny could probably help me with this answer as well, but there's quite a bit there where AI can help look at what's the most effective way from a design standpoint. Coupled with all the smart homes that we have, there's a lot of retrofits in smart homes from Google's system to Amazon as a system as well, where that's basically once you have the data in hand, if you can measure it, you can manage it, right? So not just in business, but in our homes as well. So AI can help directly with smart homes and giving us, hints and suggestions for how better to use the buildings for that. Retrofits are tough. They're expensive, especially looking at geothermal heat pumps, for example. But there's work underway to use AI to find much more cost-effective ways to design and install geothermal heat pumps. That does require drilling into the ground with trenches or actual well bore. It could be a few hundred feet, for example. So that's a tough one there. Not the best answer, but it's there, and I think there is some pretty good potential for using AI to tackle that. We do need to turn to the online attendees for a few questions there as well. Go ahead, Tara.
Thank you. We have 2 questions online and we have 8 minutes left, so I will be quick. Gary would like to know, as we pursue maximum electricity generation from wind and solar, we may end up with an inequitable and much higher per kilowatt hour cost than nuclear or Canadian hydro. Wind and solar are not a 24/7 dependable source of power. How will AI help with such challenges?
Yeah, excellent question. So when you look at utility scale PV, utility scale photovoltaic systems, they are some of the cheapest options out there in terms of a dollar per levelized cost of electricity. So it's really just noteworthy to state that. To the question though, the question is basically, okay, well, when you start layering in the fact that that energy source, being a renewable energy source that's intermittent due to the weather, sunlight, for example, that energy source does have quite a bit of downtime, especially at night, right? So anyways, the point there is that when it's operating, it's pretty cheap. But when you factor in the fact that it's intermittent, it does actually increase the total cost when you have to store that energy with battery storage, for example. So when you start to even that out, the adjusted levelized cost of electricity, and by the way, NREL, National Renewable Energy Laboratory, they have the annual technology baseline. Every year they make those estimates for how those costs change. But it is true, when you bring in a necessary energy storage device to level out the intermittent supply of energy to provide it when you need it, then that does increase the cost, and it does make it more expensive than some of the other alternatives. So AI can help with that by designing better batteries. There are several researchers at the main campus that I'm aware of, professors and their research groups that are working on, how to design better batteries, how to forecast their performance, not just optimizing performance, but also looking at the full life cycle cost and increasing the lifespan of those. So I'm already seeing AI-based applications in that area. So that's encouraging from design to operation as well. But that coupling between, let's say, source energy from renewables, solar and wind, to when we need it in terms of the total sort of energy cost itself, and with the open markets that we have, the real-time day-ahead markets, finding that right solution is a whole nother area where AI is already starting to help find the best source of energy when you need it. And that's starting to encourage and incentivize basically a more renewable type of applications. So that's one area that we're seeing that advance forward. You may have some other questions for.
Got one more. Thank you. Are near-term applications of quantum computing in AI realistic, or is quantum still a decade or more away?
Another great question on, are we going to see quantum computing go, let's say, fully commercial so we can all benefit from that in the near future? I would not start to guess at the year when we can do that. I'm not the expert by far in that area. So anyone in here is the expert, and let's say at least we want to take that question on quantum computing and when we could benefit from that, like ChatGPT. No? All right. Well, I think it's coming. Maybe sooner than you think, but I wouldn't put a date on it. Okay, because it'll be recorded, and you're going to hold me to it. Anyways, in the back, let's see. Tara, are there any other questions online? Okay, great. Okay, in the back then.
I know there are systems to aid in traffic lights and make cars more efficient. This one down here in the back code for all of us. Do you see AI being accepted for like a dynamic jump and flow through cities and traffic in general?
Yeah. So the question is, can AI help optimize traffic, but can it be accepted? So let's say it is successful at doing that. Will society accept that? I think if I can answer more generally speaking, I've seen several areas and examples of let's say companies or group rolling out AI applications. There is an initial reluctance to adopt it. Anything from, hey, I don't want my job to be taken, to the existential threat of AI in the future. So there's a lot of, resistance up front. But I'm not a civil engineer. I'm not familiar with that space, but I know of applications of AI to help with traffic management. And one item that's a major benefactor of that would be to reduce carbon emissions. So just idling at traffic lights, or idling in general, is just wasted energy. Back to the 2/3 wasted energy on the chart. It's tremendous. That's an easy one to start to tackle right there before you even switch to EVs. But yeah, I wouldn't say much more on that there is a reluctance generally in most areas. In oil and gas, for example, is an area they're trying to roll out cleaner ways to extract oil and gas, which is a really cool thing. Okay, cleaner ways to decarbonize the act of getting fossil fuels out of the ground. But in that area, I can attest firsthand that there's been quite a bit of reluctance to rolling out AI type applications. So we are seeing that more and more. So I can't talk to automobiles, but I'm a pilot, and I am aware of fully sort of automated flight. And there are new aircraft now that you could buy. Maybe we can all combine our funds for that. But there are aircraft now that if you happen to be incapacitated as a solo pilot in the plane can detect that and land itself. So that's a Cirrus small jet. You can look it up. So that's state of the art. Airliners, I believe, if I'm correct on that, the planes could virtually land themselves, but we always have a pilot, co-pilot. One of the two is pilot in command, a human, for the state of mind that we're landing those planes with a human at the controls. But yeah, I think we've advanced quite a ways, and this is what we know about. Having worked in industry for a few decades now, I can say that there's a lot that we don't know about. That, from my standpoint, it's encouraging. Obviously, there are some concerns out there in terms of what we don't know about. Quick tangent on your question, and we've seen basically the news around OpenAI replacing the CEO and bringing them back after Microsoft stepped in. There were some concern people on the board, and that I'm not familiar with the full details there, but there was enough concern to really cause basically a hiccup in the history of that company. So what was the board concerned about, right? Another example would be a few sort of Google employees that have stepped down for the company, just out of concern about how fast this is going, from Elon Musk to Stephen Hawking, and the letter of about 100 experts in the area that have all written letters to basically warn about the risk, slow down to make sure we understand AI before we go full speed, especially with general intelligence type of AI systems. So cautionary statement, don't want to end on that item there, but maybe we can pick up here with any other questions then? No? Thank you. Thank you.
I think we are out of time. Thank you all so much for coming. John, thank you. I know a little bit more about AI now. We have some ice cream and soda up here for you to enjoy, a cool treat for talking about hot things. I hope you stay engaged. If you came and hadn't registered, we have a little sign up here. If you can just add your name if you hadn't already registered. Chat with us, stay in touch with us. We will be doing these about twice a month on all kinds of different topics, and we welcome you to all of them. Come see me or Warren if you have any questions about the incubator, and thank you all for coming.